Alright, you guys, welcome to today's show. So, let's learn some electrical engineering, shall we? There are three terms that you need to know in order to understand this stuff, and they are depicted V, I, and omega. And I'm going to try to explain in a way that I think will make you understand all this stuff. Perhaps you learned some of this in physics in school, but today I believe you will actually learn all this stuff, because if you do, you will be able to build and design some remarkable things later on in this series. Alright, so to the left here we have a battery, and this right here is supposed to be an electrical circuit. But the mental model that I want you to have is that this battery, the plus side of it, is this bowl of water, okay? And the minus side is this pump right here. And this is a pipe. So let's say we start pumping here, and we have a hole in the circuit like you see here. No matter how much you pump, you will not get any flow of water anywhere in this circuit. That makes sense, right? However, if this hole here does not exist, if we have a full circuit and you pump here, the water will flow along this path here. And as long as there is water inside of this bowl, the water will flow. But as soon as this water runs out, the flow of water will stop. So that's quite logical. And electricity works the same way. And the strength of this pump is measured in volts. And let's say that we have a propeller. We mount a propeller here inside of this pipe. When we pump and the water will flow, this propeller will start to spin, right? And let's also say that we connect this to a counter. So this is a counter, CNT. And each time, if this is the propeller seen from the front, each time that this propeller makes a full circle, 360 degrees, we will increase this counter by 1. And next time we increase it by 1 and 1 and so on and so forth. If we were to count the number of laps, so the number of times it does a full circle per second, then we have a value of the strength of this flow of water, right? And this strength of the flow, so the number of laps that this propeller will do per second, that is measured in ampere, or amps as it's called in America. Okay, so the voltage has only meaning if there is water here. If this water bowl is empty, we can put 10,000 volts or whatever on this pipe, but there will not be any flow of water. So this propeller will not spin. So the strength of this pump, the voltage, that is more of a potential. In order for the voltage to be an electrical current measured in ampere, we need to have a fully loaded battery, so water in this tank. And we need to have a full circuit. There can't be any holes or anything. All right. So what if we were to shorten this whole pipe system? So we still have the same strength of this pump. Let's say we had 1.5 volts before, and we still have 1.5 volts. So that's the strength of the pump. And we have this propeller right here. What will happen with the flow of water in this case if we compare it to the longer distance? Well, in order to figure that out, I want you to consider one thing. If you have a soda mug from like a hamburger restaurant or something, and you have a straw that you drink this soda with, if the straw is 2 inches long, it will be very easy to drink this stuff. But if it's like 2 yards long, then you will need to suck very hard on it for it to give the soda. And the same is true for this pump. Since this pipe system is much shorter than before, with the same power on this pump, this propeller will spin much faster. And maybe the flow of water becomes so intense that this propeller will break. So we need to consider that when we build this kind of stuff, that all the components that we add to the circuit, if we put too much power, too much ampere on it, it will break. So we need to be able to handle that somehow, because we cannot always count on creating a long enough circuit. We never can do that, actually. So how do we solve this problem? We need to somehow artificially make this longer. And we do that by using one of these small things. It's called a resistor. So a resistor, when we make a sketch for our circuit, looks like something like this. And this explains it quite a lot. So when we put electricity through this resistor, it will take a longer path, or it will be built in such a way that it has the same effect. So even if you have the same power of the pump, if you have the same voltage and the same distance, and we connect one of these resistors, the amperes, the amps will go down. And this resistance is measured in ohms. And I'm not going to go into any math here. I'm not going to describe how to calculate all of these values, because that's not the important thing here. The important thing is that you know the difference between these three things. That the voltage is the strength of the battery, of the pump. The ampere is the flow of water. And usually, in most cases, or at least in many cases, you have the same strength of the battery. It's often 1.5 volts, for instance, and in electrical circuits, it's often 3.3 or 5 volts, for instance. So what we can change is the ohm, the resistance, and that way we can lower the amps.
Alright, so welcome back. When you do a sketch for electronic engineering, all the different components have different symbols. And a battery looks like this. So one long line and one tinier one. And then you have two connectors like this. So the side with the long line is the plus side, and the tinier line is the minus side. And if we were to connect a light of some kind, for instance a LED, it looks something like this. With some beams going off from it. And as you can see, this is formed like an arrow, and that is because it needs to be connected to the right side, so to speak. So this circuit or this component will only let the electricity go one way, so to speak. So if you turn this on the wrong side, it will not let the electricity through. And if you were to connect it like this, it would be too much power running through this LED, so it would probably break. So, as we talked before, we need to connect a resistor. So we limit the current through this circuit. Right. And if we were to connect without this resistor and just connect the two sides of the batteries like this, this is called a short circuit. And you should avoid this, you should always avoid this, because the flow of electricity will be far too high, so you will damage the battery and possibly other components, but also the battery will run out very fast because there's no resistance or very little resistance. And when you connect things, there are basically two ways you can do it. If we have, let's say, two of these lamps, these LEDs, and we connect them like this, this is called a serial connection. And when we connect it like this, both of these lights will shine as much as if we only had one of these connected, basically. But the battery will run out faster because of this. But we can also do a parallel connection, which would look something like this. So we have the first one like this, and then we connect the second one something like this. So the one side of the LED lamp is connected to the plus side, and both of these are connected together to the plus side, and same for the minus side. This is called a parallel connection. And in this case, the battery will run out as fast as if we only had one of these lamps, basically. But both of these lamps will only shine with half the intensity. So these are two different ways we can connect these things. And why does it behave like this? Well, this is because the lights, the electricity will always try to flow through the path of least resistance. But in this case, we have two possible ways for the circuit to go full circle, so to speak. It can go this, and it can go like this. So the electricity will, how could I tell? I don't know what word to use. The electricity will go, half of the electricity will go through this one, and half of the electricity will go through this one. But if we connect them in series, it works differently. So another thing which is good to know is, let's say we have a connection that looks like this. So we have one of these lights here, and same as before, we have another one here. But over here we have a resistor. So in this case, this light will not shine at all, because all the electricity will take the path of least resistance, which is through the first light. And nothing will go this direction, because this has much higher resistance, and it always tries to avoid the resistance. However, if we were to disconnect this light, then the other light will go on, because now we only have one way. We have to go through this one with the resistance. So using this technique, you can decide what path the electricity will take. And this is the basis for all the logical circuits, like in a CPU.
What's up, guys? Welcome here. So this is a transistor. A transistor is one of the most important components in electrical engineering and computer science. And the components that we have looked at this far has two connectors each, both the battery and the resistor and the LED. But this has three connectors, and this works like a switch. So let's say we have a battery here where this is plus and this is minus, and we connect the circuit like this, and let's put an LED here. So let's do something like this. And of course we need to have a resistor here as well, but let's not focus on that right now. So if we were to connect this circuit, this lamp will not be lit in this case, because this transistor works like a switch, and currently this switch is disconnected. However, if we take this middle leg right here and we put power, but if we put electricity on this leg right here, let's call this signal A. We don't need to put a lot of electricity, just a tiny signal, then this light will turn on. And we can do that either by connecting this to somewhere else, but we can connect it down here. And in this case, this transistor would turn on, but the electricity would go this way. So it will still not go out here. So we can fix this by adding a resistor like this, because there will, even though this path contains a resistor, a small amount of electricity will go this way, and this will activate this transistor, which means that the electricity will start flowing like this, and the light will be turned on. And if we wanted to disconnect this, we could just let it float like this, or we can connect it to the plus side or something like that. But the important thing is that if we have an electricity flowing through the leg, and that in turn creates a full circuit, then this will activate and put electricity this way. And this is the most important concept, because then we can make if statements. So we can create things like gates. It's also called logical gates. And one symbol for one of these looks something like this. It has two inputs, A and B, and one output, which often is just depicted as out. And this gate works like an if statement like this. So let's say we have a function which returns a boolean, so true or false, and let's call this gate. And we have two parameters which are also booleans. So we have bool A and bool B. And if A and B are both true, in that case we return true. Otherwise we return false. And using gates like this, we can combine them and create any logic. We can create an entire CPU just with gates similar to this one. And this, we can make a table out of the possible values. And when we talk about logical gates, we usually don't talk about booleans. We often say that 0 is equal to false and 1 is equal to true. I used booleans here because I wanted to show that they are 1 bit of information each. Alright, so if we're gonna make a table out of the different results of this gate, it will look something like this. We're gonna have the A input, the B input, and the output. Alright, so if A is 0 and B is 0, that means that the out is 0. If A is 1 and B is 0, or if A is 0 and B is 1, the result is still 0, right? But if both these are 1s, then the result will be 1. And this gate is called an AND gate. And you can see that here in the describing if statement. So it works same as this in C. So if A is true and B is true, then the result is true, otherwise false. And same here. If both of these inputs are 1s, then we have a 1 as an output. So this is the AND gate. And our next gate looks almost the same. It still has this shape, but instead of making a line directly across these two, we're going to form it like an O. And then we have the two inputs A and B, and we have the one output out. And the code for this is the same as the other one, except that we have an OR here instead. So this is a logical OR gate. So if both of these inputs are 0, the outputs are 0. If one is a 0 and the other one is a 1, then the result will be 1 in both cases. And if we have both inputs as 1, the result will be 1. So this is the direct opposite of the AND gate. So are you starting to see the pattern here? We have the electronic versions of these if statements. So if we can do if statements that takes two inputs and produces an output, then we can build any type of logical circuits. And there are a lot of different other gates as well, but these are the two most common, I would say, and the most important ones. So I hope you liked this episode, and please like and subscribe, because we're going to build really cool projects moving forward. So thanks for watching. Thanks for today.